13.
That's a lot of bad words.
Okay, boys. I want you to promise me you'll never use that word again.
Good morning, everyone, and welcome to Bio 411. What you just witnessed was, yes, I know, traumatizing. But no worries, because today we're going to be talking about restriction enzymes. But what do restriction enzymes have to do with what you just seen? Where do they come from? What is their purpose? And most importantly, are they friends or are they foe? We're going to find out. To help guide us as we explore the world of restriction enzymes, let's look at these three fundamental questions. 1. What are they? 2. How do they work? And 3. Why are they important? To help answer our first question, let's head over to a real restriction enzyme. I met the cutest one just the other day. Juan, what can you tell us about restriction enzymes?
Hi Maria. So girl, basically I'm a restriction enzyme. Restriction enzymes are also referred to as restriction endonucleases. I recognize a specific sequence of nucleotide base pairs and I cut along that sequence in an anti-parallel fashion. This is also known as a palindrome. Palindromic sequences of DNA are hydrogen bonded in such a way that the nucleotide base pairs are reversed with respect to its complementary strand of DNA.
Okay, now I heard there's different types of restriction enzymes. What can you tell us about that?
Keep in mind that there are 3 different types of restriction endonucleases, types 1, 2, and 3. Type 1 cuts at places as long as 1,000 base pairs or more and requires ATP, while type 3 also requires ATP and cuts at places of 25 base pairs or more. And type 2 does not require ATP and it cuts at 2 different types of places, both of which are blunt and sticky ends. This is significant because sticky ends can be ligated with its complementary base pairs, or glued together. And those are pretty much the basic facts you need to know about me. If you want to go and get to know me some more, add me on Facebook.
Wow, okay. Now we're going to talk to Dr. Nicole. Dr. Nicole, can you please tell us how exactly is it that restriction enzymes work?
Hello Maria. Well, restriction enzymes pretty much work as part-time scanners. They scan a strand of DNA looking for a specific sequence of nucleotides called a recognition sequence. Once they find this sequence, they bind to the DNA molecule and cleave or cut the sugar phosphate backbones of the DNA double helix. This results in 2 double-stranded DNA fragments.
Good question, Dr. Nicole. What are the DNAs from a different source? will they still cut in the same location in the same manner?
Yes, the origin of the DNA doesn't matter. The restriction enzyme will cut the DNA sequence in the same location and in the same manner regardless. We'll have to talk specifics about restriction enzymes forever, but I have to attend a meeting with some colleagues. I hear they want to talk about polymerase chains later on.
Okay, well, thank you very much, Dr. Nicole. Thank you for all that lovely information. Hope to see you in just a little bit. And now next up, recombinant DNA. How exciting! So, for that, we're going to head over to Dr. Austin in his lab, where he's been researching recombinant DNA and restriction enzymes. Dr. Austin, can you hear me?
Hello, Maria. How are you this fine morning? You know, I've been thinking, and I think you need to let me take you out to dinner sometime.
I'm sorry. Why?
Well, you see, Maria, the way I see it is we kind of fit together like the sticky ends of recombinant DNA, if you know what I mean.
Yeah. Okay, well, you do know we're on live, right, Dr. Austin? So how about you tell us something useful about recombinant DNA this time? Huh? Let's try this over. Dr. Austin, can you hear me?
Hello, viewers. My name is Dr. Austin, and I'm a researcher here on restrictive enzymes here at Stanford. So what is recombinant DNA? Recombinant DNA is made artificially using two molecules and two separate strands. So what do restriction enzymes have to do with recombinant DNA? Well, the process of recombining DNA could not happen without restriction enzymes. For instance, if we go over to this board over here, you'll see that we have two molecules, molecule A and molecule B. We want to recombine them, the two of their segments, into one single molecule of recombinant DNA. So we take both of them and using the same restriction enzyme, break them down into segments, each with a sticky end for the recombination over here using DNA-like. The ability to artificially create rDNA, or recombinant DNA, revolutionized the field of genetics and transformed biotechnology. Researchers can now create what used to be incredibly difficult to create and incredibly expensive enzymes in the production of insulin or other products such as the human factor 8 for men with hemophilia. Now back to you, Maria.
Okay, thank you, Dr. Austin. Moving on. Now we're going to talk about bacteria. Kaylin, hi, can you hear me? So what can you tell us about your relationship with the restriction enzyme? Is it a love, hate, or both? A love-hate relationship?
Well, Maria, I would say that it is a hate relationship between those restriction enzymes and me. Even though we're isolated from each other, when we come in contact, they cut up my DNA and put a restriction on the amount of viral strands I can use to potentially cause an infection.
Oh, okay, I see. Well, thank you very much for your time. You have a great day. Now, moving on, our last topic. To answer our last question, we're going to get everyone together right after the short message. Okay, folks, welcome back to Bio 411. As promised, we're about to answer the last question. Why are restriction enzymes important?
Well, perhaps the most important application for restriction enzymes is recombinant DNA technology, which allows scientists to manipulate genetic information.
Correct. And furthermore, restriction endonucleases can be used as a defense mechanism with which to protect against any type of foreign invasion from either viruses, bacteria, or things of the such.
Oh yeah, in agriculture, it's allowed for the development of stress-tolerant and higher yield plants.
Recombinant DNA is used for everything from making insulin and products of the such to modifying crops.
And also the development of recombinant organisms can be advantageous to us because we can use that to remove any type of environmental contaminants.
Restriction enzymes are used in biotechnology to cut segments of DNA into smaller strands in order to study fragment length differences among individuals or for gene cloning.
Well, guys, sorry, but that's it for today. Next up, prepare yourself for a wild reaction along the polymerase chain. This is Maria saying see you next time on Bio 411.